As we start digging into some more algebraic math, basic number properties come into play. There are 4 basic properties of numbers: commutative, associative, identity, and distributive. Today we are just going to focus on the first 3 that I mentioned. So we're going to take a look at commutative first. Commutative property is the order in which you add or multiply numbers does not change their sum or product. So, for addition, when 2 numbers are added, the sum is the same regardless of the order in which the numbers are added. And for multiplication, when 2 numbers are multiplied together, the product is the same regardless of the order in which the numbers are multiplied. So we can explain this in symbols using symbols A, B, and C. So as you can see, A plus B equals C is the same as B plus A equals C. So no matter which way those numbers are ordered, either A or B or B or A, they will still equal the same answer, which is C. An example of this would be 3 plus 5 equals 8 is the same as 5 plus 3 equals 8. So as we said before, using our symbols, if A were 3, and B is 5, no matter which way we put that A and B, we still get the same number. For multiplication, it looks really similar as addition does in terms of symbol. So if we were to multiply A times B, that would equal C, and it would be the same as doing B times A, would also equal C. As I mentioned before, when 2 numbers are multiplied together, the product is the same regardless of the order in which the numbers are multiplied. So again, if 6 was representing A, and B 2, no matter which order we put them in, if we put A over here and B over here, we would still get 12 for both of our answers. 6 times 2 equals 12, just as 2 times 6 equals 12. Associative, the associative property is a little different than the commutative. So associative is all about the way in which the numbers are grouped. So the way in which 3 numbers are grouped when they are added or multiplied does not change their sum or product. So for addition, when 3 or more numbers are added, the sum is the same regardless of the way in which the numbers are grouped. For multiplication, when 3 or more numbers are multiplied, the product is the same regardless of the way in which the numbers are grouped. So we'll take a look at how that looks using symbols now. So if we look here in our first example, the A is on the outside of the parentheses and the B and C are inside the parentheses being added first. The example underneath, A and B are then grouped together, and C is added after the fact. No matter which way you add, either B and C being grouped or A and B being grouped, you still will get the same answer of D. We'll take a look of how we can see that in a real example with numbers. So if we take a look at this first problem up here, we see that the 4 and the 3 are grouped together. So when we add those, we get 7, and then we would continue on to add 6 to 7, in which we would get 13. The second one down here, 6 and 4 are grouped together. When we add those, we get 10, and then add the 3 to get 13. So it didn't matter in which order the numbers were grouped. Right here we had 4 and 3, and here we had 6 and 4. But when all of the 3 numbers stayed the same within the 2 equations, we got the same answer both times. Once again, the multiplication symbols look fairly similar to the addition, but we are just noticing again that no matter the grouping of the numbers, you still get the same product or sum. So let's take a look at it with real numbers. So if we take a look at this first example again, we see that the grouping here is 2 and 3, which equals 6. 2 times 3 equals 6, and then you would multiply it by that 4 to equal 24. In this second equation example, we are taking the first two numbers and grouping them, 4 and 2, which equals 8, and multiplying by 3, which equals 24. So once again, prefacing that no matter the groupings of the numbers, they will still equal the same sum or product. So this last property that we're looking at is the identity property, and I think you guys are going to get this one pretty quick. So for the addition identity property, the sum of a number and 0 is going to remain that number. And for multiplication, the product of a number and 1 is also going to remain that number. So if we had A being added to 0, we'd still just have the symbol A. Just as if we had the symbol B and we were adding 0 to that, it would be B. So if we look at that over here, if we're saying that 12 is A, we're adding 0 to that, we're still just going to get 12. If we had 4 representing B, we're adding 0 to 4, well, we all know that 4 plus 0 equals 4. So the sum of a number and 0 is always just going to be that number. For multiplication, it's saying that the product of a number and 1 is going to remain that number. So if we had A times 1, it's going to remain A. Just the same as if we had B times 1, it's going to remain B. So if we look at that over here, if we had 9 times 1, it's going to remain that number 9. If we had 3 times 1, it's going to remain 3, that variable that we are seeing here. So those are the 3 properties that we're looking at today. Commutative, which is all about the order in which you add or multiply numbers will not change the sum or the product. Associative is the way in which numbers are grouped when they are added or multiplied, will not change the sum or the product. And then identity has 2 parts, which sum of a number and 0 is going to remain that number, and the product of a number and 1 will remain that number.